Hi friends, welcome back. Today we're talking about graphing polynomials. We're talking about your extrema and your y-intercept. So finding both of those things. And we're going to be using a free product, desmos.com. You just go out to the website and type in desmos.com. Let me show you what that looks like. You come here to desmos.com. You don't have to create an account if you don't want to, but you can. You can hit graphing calculator to graph. And it looks just like this. And so we're going to be using that tool in order to help us graph today. Okay, so first let's talk about extrema. Extrema is just the collective for your relative minimum and maximum and your absolute minimum and your maximum. What's the difference between relative and absolute? Well, relative just means in relation to everything else on the graph. So if it goes up, then it's a maximum, and if it's down, it's a minimum. Let's talk about that, the bumps that are in your graph. So for a polynomial, you take the highest exponent, so the degree of your polynomial, let's say it's 5, subtract 1, that gives you 4. So you would have 4 different bumps. They may be up or down. They may be a minimum or a maximum, but you'll have 4 of them depending on it. So taking a look at this guy. So that's what we call them changes or turning points is a better use of that. So for example, in this guy right here, we have 2 relative maximums, but the absolute maximum is this one right here. So relative to everything around it, these 2 are maximum, but the absolute maximum is this guy right here, -3.6. And then this is our relative minimum, but it's also our absolute minimum because there are nothing else that's smaller than that. Okay, so like I said, how many changes or turning points? You take your degree, -1. Generally, that's the way it works. Okay, so here is what we are going to do. We are going to graph this guy, and we're going to find our extrema and our y-intercept. Okay, to find our y-intercept, we're going to set x equal to 0. When we do that, we'll come back to that part. When we set our x equal to 0, we end up, remember, f of x is just a fancy way of saying y. So if we have y equals -0 to the 3rd plus 3 times 0 squared minus 2 times 0 plus 5. Well, all those things times 0 is 0, right? 0 times 0 is 0, 3 times 0, 2 times 0. So these are all 0, and that leaves us with just plus 5. If you have your polynomial in standard form, meaning from the highest degree to the lowest, it's generally your constant here at the back is going to be your y-intercept. And how do we write that? So remember, we set x equal to 0. So our y-intercept is, when x equals 0, we get +5. Okay, so let's go ahead and graph this now. Like I said, you go out to Desmos here and you start typing it all in. I won't waste your time typing it all in. Got it all right here for you. And then what you can do is, let's zoom in on these. You can see you can click on it to see your relative maximum, and that's also our absolute maximum because it's the only maximum we have, and then our relative minimum or our absolute minimum as well. And it's okay to round to the nearest fifth on the, or nearest tenth on these. So if you would, so then we would say our relative minimum is going to be, and if we round to the nearest tenth, it'd be 4/10, 4.6. And then our relative maximum would be 1.6 and 5.4. Okay, so let's try another one of these. So if we take a look at this guy right here, remember again, f of x is just a fancy way of saying y. So all we're going to do is plug that into Desmos and see what that looks like. And I've got that plugged in here for you. So we can see this guy right here is our relative, or this is our function, and then we have relative maximum. We have 2 of them, so these are both let me unclick the minimum. There we go. This is our relative maximum, and our absolute maximum would be this one. So you can just, again, round to the nearest tenth on that. And then here is our relative minimum. So if we come back over to here, we've got, all right, so again, we can round. So 2.2 for our absolute maximum, comma 7.3. And then we have negative 3 tenths, and then 1.2. And then for our relative or our absolute minimum, we have 0.4, 0.8 for those guys. Okay, but what about our y-intercept? So remember, our y-intercept is when we set x equal to 0. So Looking at this guy, let me slide that back down. We would have negative 0 to the 4th plus 3 times 0 to the 3rd minus 0 plus 1. So when x is 0, y is positive 1 because all of those things go away. And if you go back and we can take a look at this, you'll see that sure enough, we did cross the y-intercept at positive 1 here. We went over 0, up 1. So we crossed the y-axis at positive 1. So hopefully this helps. If you have any questions, let your teacher know. Otherwise, we will see you next time.